Here we will look at an example of an indeterminate form where we use L'Hopital's rule. So recall L'Hopital's rule. If you have a limit of a quotient where the numerator and the denominator are differentiable, and direct evaluation of the numerator and the denominator yield the 0 over 0 or infinity over infinity indeterminate form, then that limit of their quotient is the limit of the quotient of their derivatives. Here we have an example, and if we were to directly evaluate the top and bottom, we see x is going to 0, which of course means that x in the denominator is going to 0. And then if we think of 3 to the sine of x, we know that the graph of y equals sine of x, as x is approaching 0, sine of x is approaching 0. So that 3 to the sine of x term in the top is approaching 3 to the 0, or 1, which means the entire numerator is approaching 0. So direct evaluation yields 0 over 0 indeterminate form. And remember to write it this way. Avoid the fallacy of writing this equals 0 over 0, because 0 over 0 is not defined. It doesn't make sense. So we want to say that this expression, which does make sense if you try to evaluate using the limit laws, limit of the numerator over the denominator, is the limit of the numerator over the limit of the denominator if each limit exists. When you attempt to do that, you get this indeterminate form. You can then use L'Hopital's rule, since this is one of the two indeterminate forms that qualifies. And we can then say this, using L'Hopital's rule, is the limit as x goes to 0 of the derivative of the top with respect to x. So the derivative with respect to x of 3 to the sine of x minus 1 over the derivative with respect to x of the bottom, which is x. And so we have to recall how to differentiate an exponential like this. And we can do that as an aside here. So if we think of this as, if we write 3 to the sine of x as 3 to the u, where u equals sine of x, then what we want is the derivative of 3 to the u with respect to x. So the derivative with respect to x of 3 to the sine of x we can write as the derivative with respect to x of 3 to the u. But u is an intermediate variable now. And we can quote our chain rule by saying this is the derivative of 3 to the u du times du dx. The derivative of 3 to the u du is 3 to the u times the natural log of 3. And du dx is the derivative of sine of x with respect to x, or cosine of x. Substituting back in for u gives 3 to the sine of x times natural log of 3 times cosine of x. When we go back to our original problem, we can now use our result here. The derivative of that numerator is the derivative of 3 to the sine of x, which we've computed here, minus the derivative of 1. Derivative of 1 is, of course, 0. So we have 3 to the sine of x times natural log of 3 times cosine of x. And in the denominator, the derivative of x with respect to x is just, of course, 1. And when we look component-wise, we know, as we had reasoned in the previous step, 3 to the sine of x, as x goes to 0, is approaching 1. Because sine of x is approaching 0, and thus the whole expression circled here is approaching 3 to the 0. So that's approaching 1. Natural log of 3 is a constant, and cosine of x, as x approaches 0, recalling that the graph of cosine of x looks like this, and we know as x approaches 0, cosine of x is approaching 1. And we see that this expression is thus approaching 1 times natural log 3 times 1, or natural log of 3.